In this video, we'll be talking about carboxylic acids and their derivatives. For the first question, we have to determine a name from the structure provided. In this structure, we have a carboxylic acid functional group and a bromine substituent. Our molecule is 5 carbons long. Since the carboxylic acid will be our main functional group, we will put oic acid. For the bromine substituent, it is on the 3rd carbon. The name for carboxylic acid starts at the carbonyl carbon. For the next question, this reaction is going to be called Gabriel Synthesis. If you recall, this is going to be making primary amines. Our acidic proton is here, so the OH minus will take the proton off of that. Next, we add in our primary alkyl halide. And if you recall, with primary alkyl halides, this will be an SN2 reaction. Next, if we add strong acid with water and heat, the mechanism is going to behave like an amide hydrolysis. However, for this compound, we have 2 carbonyl carbons. Therefore, we will do 2 amide hydrolysis reactions. One for this carbonyl and one for this carbonyl. For this overall reaction, I did omit a lot of proton exchange happening here. However, the major product will be our primary amine in this compound here. For the next question, we have to rank the following compounds from best to worst leaving group. So for leaving groups, that is dependent on the pKa. And so the lower the pKa, the better the leaving group. In order to determine the pKa, we need to find the conjugate acid of these following compounds. If we are to rank the pKa's, HCl has a pK of less than 0. The 2 oxygen compounds have a pK around 15. Ammonia has a pKa around 36, HR has a pKa of around 60, and H2 is a pKa 40. So from best to worst leaving group, we would have chlorine, OR and OH tied, NH3, H and R pretty much tied because they are so high of a pKa, they are not going to behave as leaving groups at all. For the last question, it is asking us for the general mechanism of a carboxylic acid with a good leaving group reacting with a nucleophile in acidic conditions. We have our acid, nucleophile, and our carboxylic acid with the leaving group. Since we are an acid, or with the acid catalyst, we will protonate the carbonyl oxygen first. We will then perform the nucleophilic attack. Since we want the leaving group to leave, we would want to protonate that. And since we just put the nucleophile on, we would want to deprotonate that. Now we want to kick off the leaving group, so we will reform our double bond. And for the final step, we will regenerate our acid catalyst. Notice how we started and ended with our acid. That concludes the video on carboxylic acids and their derivatives.